This video is about modeling a situation using exponential growth and decay models and predict the future outcomes using exponential growth and decay models. So a quantity that is growing exponentially if it increases by the same percentage in each unit of time. This is called exponential growth. So the equation for exponential growth is y equals a times the quantity 1 plus r to the t power. A is going to stand for your start value, so how much money you have at the beginning or how many people live in a town at the beginning. R is going to represent your rate, and we're always going to put the rate as a decimal. And then T is going to stand for time. So when we're rounding, remember that we have to round depends on the situation. So when we're using units for dollars and years, we're going to round to the nearest hundredth, which remember is 2 decimal places. But if we're rounding to units such as people or animal, we're going to round to the nearest whole number. So keep this in mind as we go through some situations. So in number 1, you deposit $500 into an account that pays 8% annual interest compounded yearly. Write the growth model for the account. So our growth model, remember, is y equals a times 1 plus r to the t power. So when we write our equation, we're going to have y equals, a is our start value, so we start with $500, parentheses 1 plus, and we need the rate as a decimal. So if we have 8%, our decimal right now is to the right of the 8. We're going to move it 2 spots to the left, so we get 0.08 to the t power. When we add that together, that simplifies then to y equals 500 times 1.08 to the t power. So we're going to leave t as our variable because we don't know the number of years yet. So in the next one it says find the value you would invest in your money for 4 years and 12 years. So we're going to take these years and we're going to substitute into t. So for 4 years we would have 500 times parentheses 1.08 to the 4th power. So this is where our calculator is going to come in handy, and we're going to type this in. So we're going to type 500 parenthesis 1.08 close parenthesis, and we went to the 4th power, so we're going to use our caret 4, and we get 680.224. So this third number is what we're going to look at to round. So because it's a 4, we stay at the number we're at. So we're going to have it at $680.24. So let's do this again with 12 years. So we're going to have 500 times 1.08 to the 12th power. So in our calculator, 500 parenthesis 1.08 close parenthesis caret 12. So this time when I look at the third number, it's a 5, so that's going to round that 8 up to a 9, so we would have $1,259.09. So remember, because it was money, we're going to round to 2 decimal places. So let's look at another example of exponential growth. So in 2010, the salary for working at a summer camp was $1,800 for the entire summer. Each year you return to work, your salary is going to increase by 5%. So what was your salary in 2012? So we're going to let t equal 0 at 2012. So we want to know our salary. If it's 2010 when we started and now it's 2012, we want to know the salary 2 years later. So first we're going to write our growth equation. So we would have y equals, the start value is 1,800, times parenthesis, if we have 5%, remember we're going to move our decimal 2 to the left, so that gets us 0.05, so we have 1 plus 0.05 to the t power. So when we simplify, we get 1,800 times 1.05 to the t. So if we want to know the salary in 2012, that's 2 years later, so we're going to take 2 and substitute in for t. So we get 1,800 times 1.05 to the 2nd power. So in our calculator, we're going to type 1,800 parenthesis 1.02 close parentheses squared. And because this is money, this is going to round then to 1,000 $984.50. We're going to add that extra zero because remember money always goes to two decimal places. So if there's no number there, we can just put a zero. So now let's look at the other type of exponential functions. So a quantity is decreasing exponentially if it decreases by the same percent in each unit of time. So this is going to be called then exponential decay. So the same thing happens with the equation. The only difference now is instead of adding the rate, we are going to subtract the rate. So A still stands for your start value, R still stands for your rate, and T still stands for your time. So remember again that all rounding should be to the nearest whole person for populations and nearest hundredth for money or time. So in number 3, you bought a used car for $1,800. The value of the car will be less each year because of depreciation. So the car depreciates or decreases, depreciation also means decreases, at a rate of 12% each year. Write an exponential decay model. So this time, we're going to have a subtraction instead of an addition in our parenthesis. So the exponential decay model is y equals a times 1 minus r to the t power. So we're going to have y equals 18,000, parenthesis 1 minus 12%, so when we move that decimal, that gets us 0.12 to the t power. That simplifies to 1 equals 1,800 times 0.88 to the t power. So now we are going to substitute our 4 and our 12 in for t to figure out the value of the car. And this time it should make sense because it's depreciating that our car value is going to go lower the more years we have it. So in our first equation, we're going to do 18,000 times 0.88 to the 4th power. So in our calculator, 18,000, parenthesis 0.88 to the power of 4. Remember, it's money, so we're going to round to 2 decimal places. That 6 tells us to round up. So we would have $10,794.52. We're going to do the same thing with the 12 years. So we have 18,000 times 0.88 to the 12th. So we're going to do 18,000 in the calculator, parenthesis 0.88 to the power of 12. And that gets us $3,882.08. Number 4, in 1996, Tommy decides to invest $4,000 in the stock market. Each year since, the stock has depreciated, so remember depreciation means we're going down, by 2.5% each year. If Tommy decides to leave the money, what will the value of the stock be in 2005? Let T equal 0 represent 1996. So since 1996 to 2005, it's been 9 years. So we want to figure out how much money Tommy has after 9 years in the stock market. So if this is a depreciation, we have y equals 4,000 times 1 minus. Now our decimal is 2.5, so we're going to move it 2 places to the left, which gets us 0.025 to the t power. So we know that this time t is going to be 9 years. So when we substitute, we have 4,000 minus, and we can simplify this, or parenthesis 1 minus 0.025 gets us 1 minus 0.025, 0.975. And we're going to leave this to 3 decimal places because we're talking about the rate here, to the 9th power. So in the calculator now we can do 4,000, parenthesis 0.975, close parenthesis, to the 9th power. And that gets us $3,184.94. So the last thing we're going to look at is, given a equation can we figure out what type of rate this is and what type we have. So remember that for growth, the equation is y equals a to the 1 plus r to the t, which means that for growth, we're always going to have a value greater than 1 in our parenthesis. And decay is y equals a times 1 minus r to the t power. So we're going to have a value less than 1 in our parentheses. So in part A, we have y equals 45 times parenthesis 1.96 to the t power. It is less than 1, which means that this is going to be a decay problem. And to find our rate, we want to figure out how much less are we than 1 right now. So if I do 1 minus 0.96, I get 0.04, but remember as a rate we want it as a percentage then when we're talking about rate in general. So we're going to move this decimal place 2 to the right this time, and that gets us 4%. Take your decimal and multiply to get your percentage. In B, this time it's greater than 1, so this is going to be a growth. So we're going to do it the opposite. We're going to do 1.05 minus 1, and we get 0.05. So when I move my decimal place 2 to the right, we get 5%. C, the number in the parentheses is less than 1, so again, this is a decay. So to find my rate, I can do 1 minus 0.07, which gets us 0.93. And we need to move that decimal 2 to the right, so we get 93%. And then our last equation in the parentheses is greater than 1, so this is a growth. So we're going to do the growth minus 1, which gets us 0.6. So when I move my decimal 2 to the right, I have to fill in that 0, so that gets us 60%. So remember when you're trying to find the rate, if it is a decay, you're going to subtract that from 1, and if it's a growth, you're going to do the number in parentheses minus 1. And remember to always turn it into a percent.